So I want to have some fun today going through this, but we have 30 minutes. So how much fun can we have in 30 minutes? We're going to find out. And I'm going to talk a little fast. We'll see what happens. So anyways, you know who I am. I'm this guy, and I'm a recovering AppSec person. I've been in the security industry for a long time, and I stopped caring about security at some point because I decided the cloud was way cooler and had way more problems. I love problems. So I went to focus on cloud. What better way to focus on cloud than go start your own company? But my journey started before then. I was at a company called Veracode, and so there's a little bit of a story I want to tell very quickly that was a little bit unnatural in terms of, I guess, my cloud upbringing, as you will, and it's kind of where I got to this point around FinDevOps that we'll talk about. When I first wanted to bring AWS into Veracode, the first relationship I established was with our CFO, because I realized as I went to the web page to sign up, I needed the credit card, and I didn't want to use my own credit card. And so I went to our CFO and I said, hey, I want to do this thing. We need to scan all these websites. Will that be okay? He's like, all right, here's the company credit card, but you can only spend $3,000, right? Can anybody here imagine only spending like $3,000 on something significant in AWS? So I realized, all right, I have to build something within this very small window. $2,997 later, figured out how to scan all of the web applications of a major provider, about 30,000 sites, right? So I became very interested in cost very early on because I didn't want to screw this up. The problem started when we started to get the rest of the company to start using AWS, right? You give this wonderful playground to folks, and then things start getting complicated from there, right? You take the smartest engineers you've ever worked with, and it gets more complicated from there. And so anyways, that has fed into this journey that we're going to go through today. So what's the journey? So serverless, I don't know, why are we here? I really want to talk about reliability, mostly focus on that, and then how serverless changes that. We'll get into this thing called FinDevOps, and then we'll talk about the future, right? So everybody wants to continue to define this. I was trying to talk to people last night about this. Honestly, we're going to be talking about this for the next 5 years until we stop talking about it. It's the same thing is true of cloud. I ultimately just see it as we're all here because we're trying to deliver value to our customers faster than we did yesterday, and faster than we did the day before that, and faster than we did the month and the year, and continue from there, right? And to me, everything that we're trying to build on top of what we call serverless is just an abstraction layer to get there faster, right? We want to deliver customer value faster. From a technology point of view, this is just the AWS version. We can also think about serverless as a spectrum. So Ben Keogh wrote a great, you guys know Ben, right? He was up here 2 minutes ago, right? Wrote a great blog post not too long ago where he talked about serverless as a spectrum. Totally bought into that. And I like to think of serverless as this. You know, Lambda's over here, but we've got a whole bunch of other services, right? I put Fargate and Kinesis in the middle, and more serverless on the left-hand side, right? And ultimately, the reason that I think that we should think about it as a spectrum of things is because I think that cloud ultimately is the operating system. We should think of cloud as an operating system, and serverless is its native code. And that's probably what's unlocked our excitement or our imaginations and why we're here today, because we want to write better systems on top of this operating system called the cloud. Okay. The challenge, of course, is in cloud version 1, we could lift and shift our way into this cloud. We had a bunch of boxes in the basement. We just copied those onto images and we put them into the cloud, and everything was hunky-dory until we looked at the bill. But we could actually get away with that. You can't lift and shift your way into serverless. You really have to think about re-architecting, re-engineering, rewriting, all the re's. And that implies also that your culture and process also has to change with that, the serverless mindset that was mentioned earlier. So as we're going through that process, how do we build reliable serverless systems? Well, the first question we have to kind of ask ourselves is, well, what exactly does that even mean, right? Because in the cloud, everything fails all the time, right? This is something that Werner Vogels, CTO at Amazon, gets up in front of the crowd quite often, says, you can't build snowflakes anymore. Everything fails all the time. Failure should be part of your operational model. Failure should be part of how you're constructing your systems. Failure is good. It makes us stronger, right? And if everything fails all the time, then how do we even get to building a reliable system? What does reliability even mean in this context, right? And so there's a lot of ways you can get at reliability. You can think about the Wikipedia definition. You can go grab your dictionary. You can spend a bunch of time thinking about what reliability is. Remember what I was saying earlier. We're trying to build customer value faster. So for the purposes of what I'm trying to talk about today, reliability is the trustworthiness of the systems that we're building, their ability to delight the customer, right? So we're trying to build systems faster, get value faster to the audience, and we're trying to make them reliable, and what reliability really is am I delighting the customer? Everything might be a dumpster fire behind the scenes, but as long as I'm pleasing my customer, that probably doesn't matter too much, at least in the short term, that stuff's on fire. Although you probably want to put that fire out. So then, what are the forces that drive reliability? Well, so there's two pieces to this. There's DevOps, which I think of more as culture, and then there's site reliability engineering, which I think of more as practice. These things kind of came together in lots of different ways. Site reliability engineering actually predates DevOps, and I've got a couple of pieces that I focus on from a DevOps point of view, where I'm trying to eliminate silos, I'm trying to be accepting of failure, I'm trying to measure things, I'm trying to push towards faster feature velocity, and then the things that I do in my day-to-day work to try to make those things happen. So how do these forces, the culture and the practice, change when we start to build serverless systems? Well, it's kind of like an iceberg. There's a lot hiding below the surface that you only kind of discover as you get into the thick of things. So I don't have enough time to go into each one of these. I'm going to cover the ones in yellow, really around availability, efficiency, monitoring, and capacity planning, how those things in particular change. But there's some other interesting things to think about here when we think about the practice. A lot of this stuff still remains your problem, things that you have to still understand. In some cases, it's harder to understand. You're still on call, and in some cases you might discover that you actually now are on call. I think some people were talking about that earlier, and it's very important. So let's talk about the first one. Let's talk about availability. So the real secret here is that we're all learning to let go of the servers, right? That's the secret to happiness. You've got to let it go. If you really love it, or maybe you never loved it, you just let it go, right? And you'll be so much better off for it, right? That's why we're here. But what does availability mean when I'm no longer responsible for all of that stuff? I'm really dependent on the SLAs or whatever standards my cloud provider is giving to me. And remember, everything fails all the time. So things like auto-scaling and other types of automation in terms of provisioning all these things become key to making things reliable, right? If I built a very high-performance serverless system like the one Erica was just talking about, and I've got millions of invokes, not all of those are successful. But in the aggregate, it doesn't matter because stuff retries, stuff scales up, magic happens. The other piece is that efficiency, where before I had certain hard resources in my basement or maybe in my lift and shifted provision cloud that were focused on efficiency and managing those resources. That really moves towards cost as the guiding force in that, right? But how many people have been hearing that serverless is like practically free, right? Like, let's move to serverless, it'll be 20 cents, right? Here's Corey Quinn, who loves to talk about this stuff. His monthly cost is like 17 cents a month. He's got a big cost problem, right? Serverless is obviously free, so why do we even care about this? Well, the answer is that serverless is a spectrum. It's more than just the Lambda executions, right? I've got a lot of different components that I'm wiring up when I build a system in any cloud provider. And it's not just about the functions. It's not just about fast. It's not just about Lambda or Google Cloud Functions or Azure Functions, right? I have to ask myself, well, how much does the whole system and all the things that I've connected to cost? So Erica talked about how they have Elastic Beanstalk because API Gateway injects cost, right? It's a big source of cost. I have Lambda functions. They might be writing a lot of log data. How many people have had a situation where they turn on debug logs, They're not paying attention to what's happening. They check their bill at the end of the week, and they realize, holy shit, it's $10,000, right? It's happened to a lot of people. It's happened to us, right? And it's very easy to have that happen because it's a whole system that you have to understand, right? So this is a 100% serverless system, in my opinion, but it's also 100% not free, right? It's costing me money. So I need to think about the whole system when we think about cost. And that's why it's important not to think just about the functions. I think monitoring needs to transition to observability. We already talked about observability earlier today. It's really a measure, I think, is not to belabor this point, about how can you understand the system based on its outputs, right? Emergent properties are going to be the bane of your existence. Talked to a lot of people yesterday at the serverless workshop about testing challenges, and the light bulb kind of went off this morning when I was thinking about this, is that we're all trying to simulate this operating system, the cloud, on our laptops. It's a fool's errand. We're never going to be successful, right? These emergent properties will kill you. This is why, ultimately, we're going to have to figure out how we test and deploy and build differently when we go to a serverless world. Dumping all your logs someplace is not going to solve all your problems. You need to really figure out how I'm going to sample all the outputs of my system so I can understand the connective tissue and how I can do analysis without a priori knowledge, right? You're not going to know what you needed to look for until after the proverbial shit has hit the fan, right? And by the way, this isn't analysis either. I completely agree with Charity. Like, these dashboards are not solving any of the problem, and that's the most disturbing image that you can get on eyeballs, by the way. You cannot use this to solve your problems, right? I hadn't heard that before when Charity mentioned it, that each one of these is a tombstone to a past failure, but I think that's a really good way to think about it. But that won't solve your problems either, because when it goes wrong, these dashboards probably didn't tell you it was going wrong. You found out because your users called you up and said something was on fire, right? That's the worst of the situation. The other thing that changes is capacity planning. So before, you had to make sure you had enough capacity. Now we're in an auto-scaling world, but as much as we like to talk about infinite scale from things like serverless, that's really a lie. Nothing is truly infinite. And there's a couple of downsides to even massive scale, but we know there's always limits. Kinesis, 500 shard limit before you call them up and ask for more. Same thing is true. Lambda has their limits. API Gateway has their limits. Some of these limits you can call your provider and tell them, hey, please change this. Other ones you just have to work with. And a lot of times, the only time you're going to find out about these things is under heavy load on a Friday at 6 p.m. or maybe on Sunday when your cron process kicks off. So when you think about capacity planning, it's not so much about capacity anymore because you have the capacity of your provider. It's what are the limits of my provider, and is my system actually smart enough to operate within them? When I hit these limits, what's going to happen? Okay. So then let's get right into the effect on DevOps, because it's really about cultural change. Cultural change eats all kinds of things for breakfast every day. Strategy, good ideas, et cetera. Culture wins all the time. And I think there's three key things that us as a serverless community or as service developers have to think about when we start really building serverless systems at scale. The first one is maybe a little controversial. We have to stop faking DevOps, and I'll explain what I mean by that in a second. We have to care more about the mean time to recovery than the mean time before failure. Everything fails, so let's just focus on what it takes to recover in the shortest period of time. And cost needs to become a first-class metric. Before we built in the cloud, before we built in the serverless context, we cared about maybe performance and quality. Cost was a sunk thing. We didn't care about it too much. Now cost is a key metric into the health and well-architected nature of the system that I'm building or running. So let's talk about not faking DevOps anymore. So I think of DevOps as it wasn't a merger, it was a hostile takeover. One day, development got up and said, I can just do it myself. I can write some code and I can deploy. Why do I need you people? And then they said, hey, no problem, here's the pager, right? And that was a rude awakening to some people. Other folks, it was an enlightenment. That decision loop between creating something and seeing how it is working or not working in as short a period of time is a really powerful thing. But I think if you see an ops team, how many people have seen, and I'm sorry if you're on one of those teams that was the ops team that's now the DevOps team that maybe got renamed to the SRE team, which is now, I don't know, doing something new. Get embedded with the developers, become a developer. It's all needs to come together. And I think we need to, what I call, these are fake DevOps teams. We need to tie these things together very, very tightly. And effective serverless engineering, probably the most important reason, if you're really gone full on serverless, you've got to take ownership. This is totally fine, right? Everything's failing all the time. At Cloud Zero, we like to think of ourselves as always being 5 minutes away from production. Well, if you're always 5 minutes away from production and I break something, well, that's a wonderful thing. I can fix it in 5 minutes, right? Now, we don't make pacemakers or things that affect people's lives. So in those cases, you might need to be a millisecond away from production. But it doesn't mean that you can't live this, this approach. And I think it really changes your culture as well when you focus on feature velocity. If you can be moving quickly, you got to be comfortable breaking things. A lot of times we talk to people and they say, oh yeah, I'm moving really fast. I'm like, oh, so you must be breaking a lot of stuff. No, actually we're really good. We're not breaking anything, but we're moving really fast. Well, then you're not really moving fast. Right? The best way to really judge how well you're internalizing this is to ask yourself if this is okay. How many people here would deploy at 6 p.m. on a Friday? Right? One person? Thank you. Everyone should be able to do this. If you can't do this at 6 p.m. on a Friday, then you don't truly understand your systems, you don't truly understand what you've created, you don't have the tools in place to observe what's going to happen when things go wrong. If you can't do this, what are you afraid of? You know in the back of your mind something is wrong and you don't have the capabilities to understand it. We should try to strive every single day to get to a point where we would feel comfortable deploying at 6 p.m. on a Friday. Right? If we can't do that, we're just winging it. It's not professional, right? Deploys should be the most unexciting, boring thing that happens whenever it needs to happen. Okay. It's time we had to talk about cost. So if you have infinite scale, what also must you have? An infinite wallet, right? Does anybody here have an infinite wallet? Why are you here if you have an infinite wallet? My God, we should become best buddies. How can I borrow that infinite wallet? Often we talk about just the massive amount of scale that moving to cloud has afforded us, and that's a little bit. It's kind of like we talk about the good, but we really don't talk about the bad. We don't have an infinite wallet. So how many people as part of the design process is asking themselves, at what point are we going to degrade our customer's experience to save our wallet? Has anybody consciously thought about that beforehand? One folk, excellent. 2, 3, yep. Quotas. Quotas? That's excellent, because that's part of the quality equation. That's part of the solution that we're building. Otherwise, this will happen. It'll happen in the middle of the night. It'll happen to you, and you'll be staring down a 10,000 or 100,000 or who knows how much bill, because the more infinite scale we get, the faster we can go from this is awesome to, oh my God, my hair's on fire, I need to quit and go to a foreign country and hide, right? So at the end of the day, a system that puts your company out of business is not a reliable system, right? And we have to find a happy balance between productivity and progress and that type of reliability as well. So let's come back to this chart for a second. So this is kind of a big problem. We've got some kind of side effects, emergent properties, things we didn't think about. Like ultimately, what actually causes this type of problem? Somebody turns on debug logging. Nobody wrote a line of code. They just turned on debug logging. Went from gigabyte to terabyte. All right, well, how do we detect that? How do we deal with that? That's a challenge. But of course, the question is, this is a very simplistic system. Could it be worse? Anybody who asks if it could be worse it's like a setup, right? So, yeah, of course it could be worse. It could be worse in all kinds of ways. And if we're tracking cost as a metric, it actually would be something that we'd catch very quickly. But think about this for a second, this infrastructure, right? What would happen at step 7? And this is kind of contrived, but it's kind of based on some real world examples I've seen where you've got people building different parts and they're all intertwined. So I got something that writes 100 files, it drops in an S3. I've got something that invokes on every file that gets dropped in there, puts some data in DynamoDB, invokes some more Lambda, and then goes back and writes a bunch of 10 times more files into that S3 bucket. What happens? The whole system scales up to its maximum capacity infinitely, or the limits of the cloud provider, in a very short period of time, approximately 60 to 120 seconds. Right? It's pretty darn fast. And you might not even know what's happening until the you know, it might not actually even be noticeable until you get the bill, actually, depending upon how your environment's working. So I like to think of that as a denial of wallet problem. I think denial of wallet is a very real problem. It used to be about denial of service, but I have infinite service, so I now have a denial of wallet problem. And I don't want to deny anyone their wallet. So what happens if you're only responsible for a small part of the system? What if your part is a separate AWS account or a third party? What if you're composing this of lots of different services? How would you even detect that that's happening? Well, the answer is I have to make cost this first-class metric. So I keep on talking about cost becoming a first-class metric, and I believe very strongly that if you're going to build effective cloud systems, that cost has to be this first-class metric. So what is that? Well, I think it's 4 things that we expect from a first-class metric. So if I was monitoring performance or I was monitoring quality, I would expect that that metric comes in real time. What is real time? Within a time frame where it's actually relevant to what I'm doing, that it has context so I understand how it's relevant to all the other things I'm doing. I can actually measure it in a way that's meaningful, and I have a clear definition of what's good or bad, right? And it's not just a cost high, bad, cost low, good. There's some nuance to it. And so this is what we mean, or what I mean when I start talking about FinDev Ops, right? That cost becomes a first-class operational metric where I start bringing in these financial decisions into my thought process when I start architecting my systems. Simon Wardley first suggested he called this FinDev. I think Ops should be part of the party too, but of course, Dev, Ops need to be joined at the hip. I don't know how the market's going to shake out on this term. I don't really care. It's another term like serverless. The key point here is that cost becomes part of our design decisions, and that we get the financial, the development, and the operations practices working together. And it understands that there's a tight correlation between cost and a well-architected system. So where does that take us in the future? Because I'm certain that we're not all going to run out from here immediately as much as I would like, and you're going to go back and start staring at your bill. We have some work to do still, although maybe you will. That would be awesome, actually. So how does this evolve? So I think FinDev Ops, in the serverless context, ultimately replaces DevOps, right? And it's much more than just about monitoring cost. You should view the money that you're spending on your cloud provider as an investment. And you should be asking yourself, what kind of return am I getting on that investment, right? I should be tracking that return, that performance of that investment daily, by the hour, by the minute, however quickly I can get that information so I can make effective decisions as I continue to build my systems. And serverless has enabled, perhaps unlike any other technology before, the most clear path to mapping those revenue-generating activities against IT and development activities. And this is ultimately where I think FinDev Ops takes us. Right? It's not just about tracking the costs. It's who cares? We're rich, right? I understand how much my system is generating. So even though I might have accidentally been generating way too much cost on the CloudWatch side, my system's still throwing off a lot of revenue. And so maybe my dollars and my time as an engineer or a software developer is better spent someplace else and not necessarily fixing that problem immediately. Or maybe it's really easy, a change from debugged back to info, right? But ultimately, it's all about tracking gross margins, cost of goods sold. What we're building are the building blocks of a supply chain that's radically changed from the days where if I was running a printing company and I had a printing press, I would care about paper, I would care about ink, I would care about equipment. Now we need to care about all these other components, and that's my cost of goods sold. It's also important to understand how much revenue that system is generating for me. And it's also important to not just stare at the costs of the system, but also understand the other adjacent costs of this. And this is an unsolved and kind of complicated problem to solve, which is how much do all of us cost when we factor into this system, right? How much does dev time cost? How much does testing time cost? How much does any process or human resource that's associated with this also cost? And as we get deeper and deeper into this, we together as a community are going to have to figure out how much of that information we can share and how much of that is confidential. How many people would like to see their salary on a dashboard measured against all the other things? It's a little bit tough, right? But ultimately, we're going to have to figure that out. Because what we're trying to build is to map the performance of our systems, the resources that we're using, everything, as precisely as we can on the revenue generating activities that our users are coming to us to derive value from. Because we're trying to all not care about that, we're trying to be rich, right? Wow, I flew through that. So that's the story about FinDevOps. That's the story about why I think cost should be a first-class metric. I think I've got a few minutes. I'd love some questions. Is there, triggering the mic process? How many people have thought about cost before today? Okay. How many people weren't thinking about cost before they came to this talk? Okay, there's a couple of people. Excellent. I want everybody to eventually think about cost.
Does anybody have a quick question? Try to do one.
Yeah.
So I was wondering if you could riff a little bit more on your last slide, the one we were talking about, where you started talking about gross margin, right? Usually when we think about the tech stack, we think of it as a source of fixed cost, right?
Yeah.
As being part of the capital intensive part of the organization, whereas you're kind of going after a new accounting metric, right? Talking about this being something that drives gross margins, which usually doesn't get as much thought in software.
It's all about OpEx.
Is this something that actually is worth thinking about from an accounting and financial point of view, or is the truth that this is all such a small part of the cost pie anyway that this would be bike shedding to be spending too much time thinking about that problem?
Yeah, so I think it's a misnomer to think of it as not a big part of the business. I mean, ultimately, one of the best kind of competitive advantages we can deliver to the market sometimes is not necessarily new features, but actually lowering the cost for our customers to use our services. It's really important to kind of think of that as in terms of a strategy overall across all of your products or all the things that you're delivering. Because if you're delivering a very unique, differentiated service, it might be fine to charge a very large price for it. But at the end of the day, when we start to look at really complex, complicated systems doing lots of different moving parts, they're not cheap. There's a lot of operational costs in there, and the days of capex or capex of kind of it's going away. It's disappearing, and we really have to operate in a like pure OpEx model. So then the question is, are these OpEx costs good or bad? And what I see happening right now is finance team is very disconnected from the development team. They look at the bill at the end of the month, and then they come over to the development team, like the guy says, like the rent is too damn high, right? It's like the bill is too damn high, and the dev team says, well, what? We have no data, we have no metrics, we don't know. Decision A versus decision B, was one better or the other, right? And the answer isn't necessarily to go shame people about their bill, but to actually just give them the data so that they understand the ramifications of choosing choice A versus choice B. That changes the culture. That makes cost part of the decision. Because before, when we were building systems, like you said, there was a sunk cost. Somebody bought a bunch of servers, amortized over 3 years, it sat in the basement. Those were constraints that all of us as engineers had to work with. And the cloud has effectively removed these constraints silently in the night, and we haven't consciously thought about it. So I could keep on talking about that for a while.
All right, I'm going to have to start playing music as you.
Thanks. All right.
Slowly get you off
I'm going to get the hook. Thank you all. Appreciate it.
Thank you, Erik Peterson.